Having drawn the displacement time graph, now let's try to plot the VT graph, right? And the way we did it in case of displacement, we'll do similar thing over here. We'll try to find out velocity at different points in time and then plot the velocity time graph. So this is velocity v. Right? The initial velocity is known, 30 meters per second. So when the ball started from here, from point O going up, initial velocity was 30 meters per second. What will be its velocity after 1 second? We can use v is equal to u plus at, and we'll get v is equal to, this is 30 plus minus 10 into t to 1, 20 meters per second. Since the acceleration is 10 meters per second, the velocity will keep on decreasing by 10 seconds every second. So here we will have velocity of 20. In the next second, it will again decrease by 10 meters per second. So this will become 10. When it reaches the maximum height after 3 seconds, over here, its velocity will become 0, decreasing by 10. When it starts going down, its velocity will increase. Again, the acceleration is 10 meters per second, so it will increase by 10 meters per second. So here the velocity will become 10, but we will put minus 10 because the direction has changed. In this journey, AB journey, it was going up. In this journey, it is going down. So you'll have minus 10. Again, in the next 1 second, it will increase by 20. So I'll have minus 20. And finally, over here, minus 30 meters per second. So this is how we can find out the velocity of the graph. The question that must be in your mind is that since over here we have negative and displacement is also vector quantity, why don't we have negative over here? The reason is because this displacement that we have taken is displacement from the reference level 0, right? And always the object is on the positive side of, or the one side of the reference point, right? Therefore, we are getting positive values of displacement throughout, because all these displacements are on the top side or the upper side of the reference point, right? If we find out change in displacement, right? Supposing over here I create a table of change in displacement, right? Then I may have negative values, right? As I will quickly show you. Right here the displacement is 25 minus 0, so 25, 40 minus 25, 15, 45 minus 5, 40 minus 5, minus 5, 25 minus 40, minus 15, and 0 minus 25, minus 20. So change in displacement, which actually leads to velocity, is negative over here. But absolute displacement, that is displacement from the reference line, is positive. Okay, our objective was to plot the VT graph. So let's now plot the VT graph. Right, sorry, this space over here. So we'll take the velocity. Velocity is from 0 to 10. So 1, 2, 3. So let's say this is velocity meters per second. This is 10, 20, and 30. This is minus 10, minus 20, minus 30. And here we'll take 1, 2, 3, 4, 5, and 6 seconds. Okay. Now, at time t equal to 0, velocity is 30 meters per second. So the point will be this. After 1 second, the velocity becomes 20. After 2 seconds, it becomes 10. And the velocity becomes 0. 4 seconds, it is minus 10. Here it is minus 20. Then finally minus 30. And therefore, we'll get a graph like this, a straight line graph like this, which goes from the positive side to the negative side, because there is change in direction of the velocity. So and this is how we can plot the velocity time graph. And remember that we looked at the direction also while we're plotting the velocity time graph. The last question is find the graph, from the graph, find the height attained by the ball. Height attained is displacement, distance, right? So we can use the area of the graph and find it out. We have been asked to find out the height attained by the ball. That is the distance covered when the journey from A to B. And A to B journey is only this part. So I need to find out the area below this particular graph, only this much. Right? If the entire distance would have been asked from A to B and back to C, then I would have found out this entire graph, this plus this. But since I have been asked to find out only height attained, that is only half part of the journey, I am taking this particular part. And as you can see, height attained is equal to area. Let us call this O, Y, z, area of OYZ, triangle of Z is equal to half into base. Base is 3 seconds into altitude is 30. So 45 meters. If I calculate this, I'll get 45 meters. And as you can see over here also we had got 45 meters in 3 seconds. So the maximum height attained is 45 meters. This is how we can find out the height attained in the particular graph. Okay, a final point before I wind up this video is that I'll go back to the velocity, right? We found out velocity is 30, 20, 10. This is another approach that we can adopt. We can use the equation v square minus u square is equal to 2as also to find out the final velocity. Right? Okay, so let us say we are trying to find out 30. Initial velocity is 30. Final velocity we want to find out, right, with this equation. So final velocity v square minus this is 30 square is equal to 2 into acceleration minus 10, and displacement. Distance is how much? Displacement is 25. I have to take this displacement 25. So 25. This will give me v square minus 900 is equal to, and this will be how much? 25 into minus 500. V square will be 400, and that will give me v is equal to 20 meters per second. So this is another approach of finding out velocity is 20 meters per second, right? One is directly using v is equal to u plus at, and this is another approach, right? So this is how we can plot ST graphs and VT graph using data given. If supposing we were asked to find out the slope of the graph or acceleration of the graph, which we already know is 10 meters per second, but if we are asked to find out that from the graph or reconfirm that from the graph, what we can do is we can find out slope of the graph, right? And the slope of the graph in this case, is slope is equal to opposite side, or OY upon OZ, the vertical component upon the vertical side upon the horizontal side, and OY is is 30. This is 3. So that gives me 10, right? And we know slope of a VT graph is acceleration. So this is 10 meters per second square. So we have confirmed that the acceleration of this journey is 10 meters per second square. So basically I have tried to cover all the aspects of ST graph and VT graph. And once again, a final remember that the difference between the S and delta S. This S is the distance, the absolute displacement from the baseline, whereas this is the change in displacement every second, right? And for calculation of velocity, we use delta S and not S, right? Even though while we are plotting ST graph, we plot the absolute displacement from the baseline. Thank you.